Hello, my friends, and welcome to this episode of the AI Show. Friday. Hold on. I feel like I got to say it with chutzpah. It's Friday. Yeah? When I said yeah, it really didn't work with me. I'm going to turn this down a little bit. How's everybody doing? It's been 2 weeks. Happy Friday. Martini Friday time for Jay McCormick. Welcome back, my wonderful friend. Hello, Mohammed. It's good to have you. Where's everybody coming from? Let's take a look here. We have, if I'm squinting, it's because I'm trying to see. Hold on, let's see. From Nigeria. All the Nigerians I've ever met, nicest people in the universe. Yes. Happy Friday. Hello, Kelly. Graham, hello, my friend. Welcome from LinkedIn. I am pushing to LinkedIn. I feel like anytime someone from LinkedIn is like, hi, I'm coming from LinkedIn, I'm all like, maybe I should be wearing a tie. You know what I'm saying? From Pakistan, welcome, my friend. Welcome. I'm like blind. Jagath, welcome, my friend. Igor Metodio. I don't know if I said that right. Where's everybody coming from? Tell me where you're at. I'm coming from the wonderful state of Washington, where we have wonderful weather for about 3 months. And today is going to be one of those days. I'm pretty excited again. We like to do this show on Friday for a couple of reasons. The first reason is because Friday is like a chill day and we kind of all want to chill out. You know what I'm saying? And so this 2-hour live show is so that when your boss comes over and it's like, she's sort of like, wait, why are you watching videos on Twitch or Twitter or wherever you're coming from, or Learn TV? You could say, I'm just not watching a random video. I'm learning how to do AI. And they'll be like, oh, I'm so sorry. Yeah, you'd be like, I just missed important plot points, Sally. Okay. From South Africa, welcome. South Africa, oh my goodness. The very last trip I took, my friends, overseas was in 2019. Was it 2019? What year are we in? I think it was 2020. Wait, when was the last? What? Who are we? I went to South Africa. It was an awesome trip. And it's the last one I went on. Mary said, hello from wild, wonderful West Virginia, Country Road. Take me home. Yes, sir. Mark. All right, so let's get to it. What do we got going on today? I have here my handy-dandy COVID purchase. A Wacom. Every time I say Wacom, I feel like there needs to be an echo. Wacom tablet here. I'm pretty excited. We got a good show for y'all today. Hopefully we'll get some stuff done. Last time we almost did a thing. I think I figured out how to fix it. Number one. Okay, here we go. Let's do this one. Number one. Paul plus Alvin. NVIDIA DeepStream. We'll do that one. We'll do that one first. It's going to be awesome. After that, oh, what did I just do? I think I leaned on it wrong, and now it messed it up. Here, let me zoom in again. Paul and Alvin, NVIDIA DeepStream. Now I'm going to have to write smaller, but that's okay. Number two. We're going to finish our Hugging Face deblurrer. Remember how we almost got to it? Like, literally, we were like, oh, and then our time ran out. That's okay. All of the stuff that I do here is almost always live, and so you're seeing me mess up all the time because the reality is the reason why I want to do a longer show is because I wanted people to see what it was really like to do AI work. And it almost always involves not getting it right. So I wanted to show you that. And if anyone cannot get it right, I'm going to be that guy for it. I don't know if that came out right. Number 3. If we get that working, we're going to go back to our Rochambeau project because we got to start game planning. Because now that we're almost done, I also figured out that there's something wrong. And so we're going to debug this thing because the pictures weren't coming across really good. So we've got a lot of stuff to do today. That's what we're doing. All right. So let's see. Mohammed's asking, is this session... Hold on, let me zoom in here a little. Okay, cool. Oh, not bad. Okay. Is this session for absolute beginner with MS Azure? I know DeepStream pretty well, but not sure about MS Azure. Oh, well, maybe. I mean, we'll ask. The way this works is the guest comes on and we do this show that's supposed to be recorded, and then we put it somewhere else. And so they have agreed to ask questions. Is NVIDIA giving out GPU cards for attendees, right? I asked Alvin. He is going to be parked at Wabash and Lake in a dark van, and he will be. Let me add these people. Hey, Paul. Hey, Alvin. So
hey,
you're going to be parked at Wabash and Lake with the van, right? And people just got to show up, and you're going to be selling them, right, out of the back of your van. Is that what we decide?
No, sadly, no. If only.
Oh, man. Okay, so I have something for you. This is what everyone just felt. Are you ready? I actually did get an NVIDIA GPU, a 3080. My friend, who actually works on the ASP.NET team, Damien, he likes building these things. Like, hey, I'll build you one and just pay me for the parts. And I'm like, great. And he happened to get an NVIDIA GPU. I was pretty excited. Hello, my friend. So how you doing, Alvin? Paul?
Doing great. Yeah, appreciate being on the show.
Great.
Is everything treating y'all well?
Happy it's Friday.
Yeah,
love
yeah,
the
that's well said. Happy Friday.
Yeah.
I love
We're
the
in the
Go ahead. Sorry.
yeah, we're in the pre-GTC stuff. So right now, the next couple of weeks as we start getting ready for GTC, it just starts getting crazy.
I gave a demo at GTC once, Alvin.
Oh, nice.
It's the greatest demo ever. People cried. They laughed. They forcefully removed me. I mean, there was a lot going on, but I mean, I don't think performative dances work at GTC anymore. I think there's a rule, and I'm just kidding. Of course not. All right. So, are you okay staying afterwards and answering questions?
Sure. Do my best.
You too, Paul. By the way, Paul and I have been working together since we were babes in cradles, right? Is that?
It's been a while. I know the anniversary's in the month of September when the first time we ever met.
You don't remember the exact day, man? I remember where I was, what I was.
It's very near to my birthday. I know that. So yeah, I actually think it's like September 9th, something like that. It was the
Wasn't
code
it
match.
like in Ohio or something?
Yes. It was very cold and it was snowing. Yeah.
It's why the snuggling was so good for me. You warmed my heart with your smile and your words. Hold on. I got to say this again. Hold on. Here we go. Paul, you warmed my heart with your smile and your words. Did you feel the collective eye roll across the world here? We have people from South Africa, Nigeria, the United States.
I don't know about y'all, but I felt that.
So, I felt it too. I felt something.
Yeah, I hope everyone felt that. Yeah.
All right, we got to pay the bills today, friends. Are we ready to do this?
Yeah, let's do it.
All righty. So let me get my Word doc over here, so I know what's going on. And just a couple of things. Make sure you look at the camera the whole time, unless you're doing your demo. Oh, by the way, is your screen up, Paul? Let me see if I got your screen here. I do. Nobody look at this. This is secret. No, don't look at it just yet. Just want to make sure. Okay, now we're gonna be serious. This is the serious part. Let me get a sip here of my drink. We're ready. We're ready to go. Okay, so just a couple of rules. Make sure you look at the camera the whole time, unless you're doing the screen. If you're not looking at me, I'm going to go to your screen. If you run out of things to say, stop talking. Don't say things like, "Can we do that over again?" Because then we have to. I remember one time, aside, I was doing this for Channel 9, which is what there was a Channel 9 before for Microsoft, and this dude stops in the middle of his presentation and he looks at me. He's like, "Can I do that again?" And I was just like, "You kind of have to, bro."
Yeah.
But you guys are cool, so it's gonna be awesome. Okay, you ready?
Let's do
this. Let's do this. Let me get this up here so that I can be ready. And I got the title here. Very good. Okay. You're not going to want to miss this episode of the AI Show where we talk to Paul and Alvin about NVIDIA DeepStream development with Microsoft Azure. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about NVIDIA DeepStream development with Microsoft Azure. We've got Paul and Alvin with us. Why don't you introduce yourself? We'll start with you, Alvin.
Yeah. Hi, everybody. My name's Alvin. I do product marketing for the NVIDIA AI SDKs. So really, my job is to help users embrace the power of AI with software tools, making it easy for everybody to do it.
You're already making me happy, Alvin. Let's go to you, Paul.
So my name is Paul DiCarlo, and I'm a lead within the data and AI team over here in developer relations at Microsoft. And a lot of my day-to-day work / interest often involves how can I make some hardware thing from NVIDIA work with some cool cloud thing from Microsoft. And it's a never-ending joy because there's always something new and exciting from both sides. And it's very fun to find out ways to use them together.
Well, I'm a fan for sure of Paul and the work that you do, Alvin. So let's start with NVIDIA DeepStream. Alvin, can you tell us a little bit about that?
Yeah, absolutely. If you, Paul, if you want to bring up that slide.
Yeah, let me get that right now. Here you go.
Yeah, great. So, yeah, anybody that's ever dealt with video or image processing knows that there's just a lot of rabbit holes. You can get into the mathematics of scaling, of changing color space conversion. You can get into how do I, share frame buffers, pointers, because you got video coming in at a steady cadence, 30 frames per second, 60 frames per second. And of course, once you have your AI inference model, you of course want to run that as efficient as possible. So DeepStream is all about end-to-end optimization and acceleration. We're built on top of GStreamer. That's a open source community that said, hey, building this video pipelines, we need an easier way to do that, to do so. And so we kind of built on top of that and say, hey, how can we make the input, the capture, the decoding, the pre-processing, the backend, the tracking, all work as efficiently and optimized as possible, whether you're running on a Jetson device, whether you're running on one of our discrete GPUs, or whether you're throwing your application up on the cloud.
Interesting. So let me see if I understand this right, because I'm a computer vision guy, not like a TED Talk guy, but like the actual pictures and stuff. So you're telling me that what DeepStream does is it takes like video streams and does a bunch of conversions on it to prepare it for machine learning or for any other application. Am I getting that right?
Yeah, absolutely. Yeah.
So
So we take things. Let's say you're running on a Jetson device and you got a RTSP stream coming in. So we're ensuring that decode is happening with our NVDEC. So you're using that hardware accelerator when you're putting in that pipeline. Let's say you got to do scaling or you got to do color space conversion. So you want to make sure you're doing that on the GPU. You want to use our GPU CUDA cores or et cetera, so that it's all about computer science. It's all about Amdahl's law, right? When we kind of talk about the efficiency is only as good as your kind of how good you're running that slowest part. So for example, you got 30 frames per second coming in, 33 milliseconds. You built this awesome AI model. It runs at 2 milliseconds, but when you actually go to put in your input stream, you find out that your decode is taking up 40 milliseconds. You're scaling certain 45 milliseconds, and all of a sudden you're scratching your head going like, hey, why am I only getting 10 frames per second? So what DeepStream does is ensuring that you're not starving that AI inference model. You're giving everything as efficiently as possible. And the same thing that the back end, whether you're doing tracking, video analytics, throwing stuff up to the Azure cloud, that's running as efficiently as possible so it's not throttling the upstream video pipeline.
that makes a ton of sense. So whenever I'm seeing like those images of like cars and boxes around it, all of that video needs to get processed. And what you're saying is that we want to process that on the GPU so that those boxes can be drawn cleanly once the inference time is happening.
Yeah, absolutely. Right? Yeah, and even the output video rendering, right? Like drawing the bounding boxes. That you want to do that on the GPU, and you want to render that using the GPUs, because imagine everything's running on let's say you got the inference, so that video frame is down in the GPU memory. If you want to say, okay, I'm going to go draw the bounding boxes with my CPU, then that memory is going to come back up to the system memory. You're going from kernel to user space, then you're drawing it, then you got to send it back down, and then all those copies just take up a lot of time, and so your end-to-end latency really hurts. If you're able to take advantage of what GStreamer and DeepStream do, is you're keeping those frame buffers down in that accelerator memory, and you're getting that accelerator to not only do inference, but also potentially do the video rendering, the bounding, box drawing, and so it kind of helps accelerate everything end to end.
And that makes a ton of sense. And when you said like a Jetson Nano, I want people to know a Jetson Nano is like a tiny computer thing, right? It's like the size of a credit. Oh, look at it.
Yeah, there you go. Paul's showing.
Paul's showing here. Let me make us bigger. Show it that thing. So you're talking about doing all of this on that thing, right?
Yeah, absolutely. Yeah. No, so what's really nice about DeepStream, and it expands to that, is that you put together your pipeline, and assuming all the resources are there, you run it on the Jetson. That same application can run on a discrete GPU. You can send that same application to the cloud. You don't have to kind of recode it. Let's say you support one camera stream on a Jetson Nano. You go to a discrete GPU. You can execute that same pipeline multiple times, and now you're supporting 50 streams, 100 streams, 150 streams on a discrete GPU. So it sort of scales and has the agility there as when you're putting together these applications.
So let me ask the hard question here, Alvin, because when I look at this stuff, I'm like, those are some cool boxes, but now I'm gonna have to write some C++ or something. Is this what I have to do? So help me out. How do I actually use the SDK? Am I gonna have to like do
Yeah. So if we can go to the next slide. So it all starts with those hardware accelerated DeepStream plugins that I talked about, right? Those are those blocks that make up the video pipeline for like the decode, the scaling, the tracking, and those are all optimized. Now you can work with those both in Python and C++ from a coding standpoint. But then you're starting to have to know a little bit about how GStreamer works, the configuration, syncs and pads and all of that, especially if you're going to do a little bit of customization stuff. And so for this last version of Deepstream 6.0 that came out in November, we wanted to take the ability of Deepstream and being able to do it visually with visual programming. And that's where Graph Composer comes in. And that's the newest way of being able to develop with Deepstream. So we're already visualizing this video pipelines in our heads as, hey, I got my input stream, I'm going to do my decode, then I'm going to send it to the inference. I might want to tap here and then look at how much FPS I'm getting, and then I'm going to do my on-screen display and my video rendering. And we said, well, why not just create a visual programming method so that you're actually programming Deepstream in that way? The way you're visualizing it, let's do it with Graph Composer. And any of those things, you can then, as you can see, you can take Container Builder, which generates little Docker images, and you can send them anywhere from Jetson to the cloud. So early on, we, of course, reached out to Paul and said, hey, Paul, we got this kind of cool new low-code, no-code way of creating these Deepstream processing pipelines. Do you want to take a look? Do you want to see what it is and give us some of your feedback?
Well, this sounds awesome because I have used GStream because people don't know this, but I wrote a little bit of Learn TV, like the back end, production. If you're watching on Learn TV, I wrote the back end, and that stuff is hard. And so if you're telling me that I can totally just embed like machine learning and post things and pre things into the video pipeline with just drawing, I'm not going to believe it until Paul shows me. So Paul, what do you got for us?
Well, I'm happy to say that it's real. You can do these things, and this is it. So this is the NVIDIA Graph Composer. And what I sort of got up here for now is a very simplistic pipeline. And part of the reason for doing that is I don't want to go into like full details and sort of overwhelm everyone. I want to give you something very easy that we can all think of visually, and then you can sort of see it here in action and sort of really make sense of how this thing works. So what you get is what feels like a familiar sort of IDE type of environment. And all the way over here on the side here, you'll notice that we have a number of what they call extensions that have components inside of them. These components can be dragged and dropped into the editor area. And from there, you can start to draw connections from the various different output nodes into input paths or source inputs that might be available within those components. And what you're seeing here is actually leveraging underneath the hood the methods that are contained within the Deepstream SDK. So for example, when you see this one, the NVIDIA single source input, if I was to click on this, you'll notice that it's going to start to bring up details about what comprises that component. And what this means here is that we can see this is me specifying a video file that I'm going to take as input from this specific path. So this MP4 file, essentially. And what that's going to do, it's going to pass into something we call the NVIDIA Stream Muxer. Now, why we're using a muxer is because you could theoretically have more than one video input. In fact, on the NVIDIA Jetson Nano devices, I've had success running up to 8 simultaneous MP4s. If you go higher onto, say, like the Jetson Zader, you can run up to 32 if it's in certain formats. You can even go higher than that if it's in a more compressed format. From there, we can put that into our inference processing, so the infer step. And this is where we actually designate the model that we want to run the object detection algorithm. And you'll notice that this has some outputs here that do couple things. One is it's going to output the video, the result of essentially the bounding boxes that would come onto that input video that comes out of the muxer, and basically draw those bounding boxes on top of it. And what we can do then is take the results and pass them into something called a per class object counter, which is going to allow us to know the totals of, say, a specific object that's seen in that video, and then also be able to render an on-screen display that allows us to basically draw things on top of the resulting video output. And the final result here is this NVDS renderer, which is actually going to show the video output. So what's really nice about this, and probably my favorite feature, is just how tight this makes that developer loop for when you're using or defining an intelligent video application using DeepStream. So we've got our visual representation here, and it should be simplistic enough. I think everybody sort of understands the flow here. We take a input source file that then goes into the muxer because it's a single source, a single output comes out into the inference step, which then counts all of the objects being detected and also draws onto this on-screen display, things like bounding boxes and other features that you can configure, and then outputs that in video. And so if you want to see that running, what's very cool is I can literally just come here and click Run Graph. And this is going to give me some options here, and I can select Run. And there we can see this pipeline ingesting that video and applying that inference that we specified in the inference step. And you'll see here it's also able to essentially give us those total counts of objects that it sees. So it's a really, really tight developer loop. You can very quickly go into like, is this thing working? Is it doing what I want? Swap in and out new models and various other things. Now we've only scratched the surface here by essentially showing you the most like simplistic pipeline, one video coming in, applying inference, and then showing that results on screen. But that's not where it stops necessarily. You can also have your results, if you choose, you could output those over, say, what we call the NVDS message converter broker, which will allow you to push any results into things like an MQTT broker. And ultimately, that means you can push into something like an Azure IoT Hub and effectively see those results as data points and then be able to process those using various data services within Microsoft Azure. But it doesn't just stop there. While we're showing that we can build this tight loop and execute this locally, Alvin had already hinted at you can actually take anything that you build with these and deploy those out either to a discrete GPU like an x86-based server machine, a cloud-hosted VM that has an NVIDIA GPU, or even that NVIDIA Jetson embedded device line for smaller form factor devices that might perhaps run at the edge. And one of the cool tooling features that allows you to do that is the container builder. And so you can actually invoke this by clicking the cloud icon over here on the left. And you can very easily specify if you want to build for, say, an ARM64 platform or maybe an x86 platform. You can very easily do that by editing the configuration. And then once you've got that created or specified to your liking, you can just go ahead and build the container. Now, the cool thing to note here is that once you have that container, you can actually deploy that into something like Azure IoT Edge, which is a container orchestrator for edge devices that allows for easy compatibility with pushing those data results into Microsoft Azure. And the great news about that is while we could show you a demo, we'd actually like for most of you at home to be able to try this yourselves. And the great thing is we're actually supporting that with a full-on NVIDIA DeepStream development with Microsoft Azure learning path on Microsoft Learn. So before I jump into that, just want to make sure that all that was clear. Seth, see if you had any sort of questions before we go on, and then we'll sort of talk about how you can get started with this today.
No, that totally makes sense. It's basically because before I would have to write some code, I would do stuff on the GPU, and then I'd have to bus it on over, to the CPU, and then do stuff. And then you're saying all of this is happening in that single pipeline of stuff.
Yep, exactly.
Correct.
And that's
and within that environment, yeah, and it's so easy to iterate, right? You can just start with a blog, start with a video renderer, just verify that you can
Someone's at the front door.
verify that that your video is playing, and then you can just start adding block and test, block and test. And it's very easy to, you can do very easily do probes. One of the other cool things that Paul didn't touch on is that, let's say you're already using you have a custom GStreamer plugin. Or let's say you have a particular camera and that camera vendor has or provides a GStreamer plugin in order to interface with that camera. Graph Composer allows you to automatically create extensions out of existing GStreamer. So all you have to do is, as long as GStreamer can find it, it's installed, GST inspect, then you just bring up that menu, say, hey, this is the plugin I want to wrap through an extension. It'll generate it, it'll be there. So it's very easy to incorporate your own custom GStreamer or DeepStream extensions, as well as third-party plugins as extensions in Graph Composer.
I mean, it's really cool. Like, and the fact that, and I don't know if people recognize, but just that entire pipeline, you having to write that yourself, weeks, if not months of figuring it out. And you're saying now I'm going to have to download it post haste, because it's something I've been wanting to do for a long time. So let me ask you just a couple of final questions here. Where can people go to find out more about this?
So developer.nvidia.com and the product page for DeepStream SDK. There's going to be a getting started link, has everything great. But really the learning path that Paul has put together is really, really great in terms of an introduction to Graph Composer. So I have been, even though it's from Microsoft, we work jointly with it. And it's kind of my go-to when someone tells me, hey, how do I learn Graph Composer? And I'm like, go talk to my buddy Paul. He's put this thing together. It's free. It's available. It's great. And yeah, so I can't rave enough about it.
Awesome. So Paul, can you give us maybe a 15 to 30 second elevator pitch on what the learning path will do for folks if they go to it?
Sure, absolutely. So it's actually comprised of 3 modules that take you all the way from the steps involved in setting up and configuring the DeepStream development environment. So this is going to be how you actually install any of the dependencies, what those hardware requirements are, for example, what sort of graphics cards you might need, gets you up and running with your sample applications. And from there, you're already going to start doing damage in an optimized fashion with some sample DeepStream applications. But then we go further. After we sort of give you that taste of what is DeepStream, we then show you how you can use Composer. And again, I think it's very important that you learn them in that order, because if you just dive into Composer without knowing DeepStream, you're not going to really know, I guess, the damage that you could do with the tools that are included there. And from there, that's going to allow you to basically understand how you can build applications. But not only that, it's going to give you a deeper understanding of those containerization options that we sort of showed there earlier, or sort of glossed over, and show you how you can even publish those into an Azure Container Registry. And then the final piece that I think is absolutely the most important is deploying those containerized DeepStream workloads to an embedded device utilizing Azure. And we actually go through and do this using the Azure IoT Hub and something called Azure IoT Edge.
Oh,
so this allows you to orchestrate and deploy this sort of at scale. And if you had a fleet of devices, shows you how to do that and get those up and running, and really teaches you how you can go not just from creating that pipeline, but go to production with a true edge to cloud AI inferencing solution powered by NVIDIA and Microsoft.
Yeah, what's really great about Graph Composer is, even though it's visual programming, it might look like, hey, this is great for hobbyists or whatever it is, but you can really build market-ready products with it. There is no performance degradation. All the extensions, all the way underneath there, it's still our optimized engines and software blocks and stack. And so it's really, you're getting all the power of DeepStream, all the power of your NVIDIA platform in a really easy to use, intuitive UI in order to build these vision applications.
Well, I'm going to go and download that right now. Again, if you want to learn more about the DeepStream SDK, just go to developer.nvidia.com/DeepStream SDK, and then the Learn modules that you saw Paul so wonderfully created for all of us at KA.MS Learn DeepStream. Thank you so much for being with us, my friends.
Yeah, absolutely. Anytime.
Awesome.
It's a pleasure.
You've been learning Oh, you've been learning all about NVIDIA DeepStream development with Microsoft Azure on the AI Show. Thanks so much for being with us, and hopefully we'll see you next time. Take care. Wow, y'all are champs. Oh, I don't know what was happening, Paul, but when you were running that GPU stuff, the computer was like, because your voice was like, did you
Oh,
hear
that's
that?
interesting because it was running on another
I
computer.
did,
Yeah, that's interesting. But okay.
I might have you record that part again if you get a chance. It's because the audio was a tiny bit choppy, is what people were telling me. Let me see.
Boy.
Let me see. But look, Janus Q7, it's magic. This is everyone's loving this. It's magic, some would say. Nice, an MS learning path. That's cool. Muhammad's telling us your voice was breaking. I think it was part technology, but also part excitement. Right? Part excitement. What else we got? Oh yeah, audio compression. But here, Kevin Oliver talking about the Jetson Nano. It is a really cool board. When it came out, I bought one, and it's still sitting there, longingly looking at me, ready to do a project. And now I think I can with DeepStream, right?
Yeah, no, it's great. Yeah, I think I have the TX2, the Xavier, the Nano, so I got a collection myself.
Okay. Yeah, I mean, I think it's really cool stuff. All right, friends. Anything else you'd like to add before we go on the download for our friends here that are watching?
No, if you can, GTC will be virtual this year. We'll be having the latest updates on DeepStream there as well. I believe Paul's got a session at GTC as well this year. And so yeah, please check that out. And definitely looking forward to getting all the great feedback and seeing what all the great projects that people put together with Graph Composer.
Fantastic.
And if you like this content, I believe the session we'll be doing for GTC will literally be a live walkthrough of that Learn module. So you'll get to see in action, get a little bit extra details about that. And it'll also be a session at GTC, which is free for attendees, I believe, since it is going to be virtual again. So definitely register for that and come say hi to Alvin and myself, and come learn about all the cool stuff that's going on there, because they say it's the best AI conference in the world, and that's a high praise. So definitely come check it out, see what it's all about.
Like I said, for those Jetson fans, Jetson Developer Day as part of GTC. Check it out.
Yeah, ever since I haven't been talking at GTC, it's been much better, is what I've been told. Just kidding. No, I did a demo on some of the cool stuff that NVIDIA is doing to hyperscale Kubeflow, which was really cool. And so we did that was like 2-3 years ago. So it wasn't. But anyways, my friends, it's been a pleasure seeing you, and hopefully I'll see you soon. Okay.
Yeah. Thanks, Zach.
All right. We'll see you later. Take care. All right. I don't know about y'all, but that was cool. Now I feel like I need to download it and try it out, I don't know. Okay. All righty. Let's go to my screen here. Add to stream here. Yeah, that was cool. I had a good time with that. I learned a ton. Okay is right. Now a reminder of what we're working on that I almost finished. This was 2 weeks ago. Let's go to Hugging Face here. Let's see. Let me bring up on my other screen here behind us. I was looking at Stack Overflow because I found an error. Let me go to the bottom thing. This one here. Hugging Face. Hugging Face. Hugging Face. Huggingface.co. And I think it was GFP GAN, this one. What we decided to do, you remember, someone's asking for help. My game bar is not launching. Help. Hold on, I gotta. His game bar. is not launching. That's about as much as I can do for you. Sarcastic share. Is empathize with you. Okay, so we were working on this thing, blind face restoration algorithm towards real face images, and this is where we got to. We got to where it was kind of working, I think. Let me close this, and then Control Shift, because I want to start on the right virtual environment. Okay, let's see what we got. Python. I think I lost the image there too. Soldiers.jpg. Is it in there? I got FAM. No, that one's cool. But we want to do the soldiers.jpg. So let me. I don't think I have that. I must have. Oh, here it is. I found it. I found it. So we're going to right click here, reveal in File Explorer. Here it is. And what we're going to do is data soldiers. Okay, so these are the soldiers that we're looking at. Remember, this is the image. Some of American heroes here from looks like the Civil War. American heroes. And let's see if it worked. So Python score. Now, if I remember right, I don't think it worked. Yeah, remember, this didn't work. Okay, so what I'm going to do is I decided, and let me put myself to the side here so you can see what's going on. I decided, why not use a dev container to run everything in a dev container? Because then we would know if it worked or not, right? And that's the thing that I thought we should do is let's make a dev container and run inside of the actual container to make sure that it works. And then the other thing I'm going to do is I'm going to use the smaller model first to see if we can get this to work. Okay. So for those that are wondering what the heck Seth is doing, I am at Hugging Face. I downloaded this particular model, this one, and I'm going to try to make it work on the soldiers thing. JPEG should be ping. Oh, it's not working because I'm an idiot. Thank you, sir. Thank you, sir. This is why I do this, so that everyone can hold on. Who is Ian? Ian, thank you, sir. Thank you. But I don't think it works anyways. If I remember right, it didn't work. There it was. This was the actual error that we got last time because there was some package that wasn't working all the way. Okay. The other thing I realized is that if you go to let's just try to get to work and then we'll make it work in a container. The other thing that I recognize is if you go to the actual code, let's go to files and versions here. There's like a how to clone. This thing is on GitHub. Okay. Main. Okay. GFPKN1 model card. Project page. That's cool, but I want the actual. There's the paper. There's the collab demo. There it is. There it is. Okay, there it is. The thing I realized about this is that it has a setup.py, which means there's probably a library for it. By the way, thanks, Ian, for helping a brother out. And this has got to be the name of it. So if I go to pip, here we go. There it is. Yeah. And what happened is last time I spent all of this time recreating this when I didn't need to. And by this, I mean, I copied all the classes and took stuff out. So I'm going to take this out. Here, let me go over here to the virtual. I'm going to take this out. And then what I'm going to do is in this thing, in the requirements.txt, I am going to add this GFP GAN. Now I'm going to say which pip, what's the right one? Pip install GFP GAN, and now, I should upgrade pip real quick. This always bothers me. Should I be bothered about not having the latest pip? I don't know. Okay, there we go. Okay, so now in theory, this doesn't work, but I can say from GFP GAN import GFP GANner. Okay. Let's see if this works. This might break, but that's okay. Oh, snap. Okay, so looks like it's trying to load the GFP CAN clean one. So let's change this to this one here. Rename, Control C. Which is the simpler one. So let's try that. Looks like there's still a problem, but that's okay. We'll figure it out. I think it's because of the way that we're calling it. So let's go over here. And let's make sure that we're calling the right things. Remember, we took some stuff out. So let's go to definition. Okay. So, I know what we'll do. We'll go to the actual original, this. Because originally we call inference GAN, we give it the model path and then the test path, which is a bunch of images, but we changed it to just one image, if you recall. So let's go to that. So I think I have that folder. Let me go to my projects here, GFP GAN, and then let me open this up. Show more options. Sorry, show more options. Open with code. So this is the original code from Hugging Face. And if this is too small, let me know. I can make it a little bigger. And so what's getting called is this inference GFP GAN. And what's happening is there's an upsampler. Okay, the architecture thing, this is what we need to be calling. But I think I took something out last time that makes it not the same. So let's make this go down, and let's take this out. And doop, doop. So model equals. The path is going to be our model path here. Model path. Okay. The upscale on the default one looks like it was 2, and that's what we left it at. The channel multiplier was 1, and the upsampler was none, because we're not upsampling the background, just the faces. So this is the architecture part that I took out last time that I didn't need to. And if you don't set it, the default is clean. So let's do clean here. Okay. So let's take this out. This is about the same here. And let's see what happens when we go back to this thing right here. Okay. Oh, shoot. Something is wrong with the size. So face unblur. Let me make sure it's all going to the right spot. Face unblur, model, GFP GAN, clean V1, no CE-C2.pth, which is right. Okay. Let me go back and take a look at that because maybe there's something wrong with the upscaling. Because my guess is that when you upscale, there's going to be some errors in the size. So let's go over back to the old one here. And looks like it's the upscale. Where does upscale come from? Upscale. Upscale. Looks like the default is 2, which is what we put in. So args upscaler, boom. BG upscaler, boom. Else BG sampler. Does this get changed anywhere? Let's take a look here. Upscale default 2. Okay, let's see what the call looks like here. Because I think we're using the simpler model. Okay, let's look over here. Okay, so for the quick inference, we use this one. Looks like upscale is 2. Let's try upscale equals 1. Just for the hay of it. Well, I mean, no. Let's go back. Maybe that's the channel multiplier. Channel multiplier. Channel multiplier. Args.channel. F. The default is 2. What do I have? Oh, I have 1. Okay, let me put 2 and see if that fixes it. Okay, here we go. Here we go. Here we go. Are we ready? Are we ready? Did it? Okay, something's wrong. It's doing something, but I'm doing something wrong. Look at that. That's cool. Look at how it's... Okay, so it's doing something. But I don't think we're doing it all the way right. Okay, so we've got to a place where it's doing something, but now we need to see what's going on. So looks like it's saving cropped faces and then saving the restored face. So I don't want to save the crop faces. I just want to save the restored image. So I don't need this. I don't need this. Stored image is not none. Something's wrong with this out path, if I'm going to be honest with you. Oh, I think it did restore it. It just overwrote it. Oh, man, I just overwrote my data. That's not cool. Oh, crud. Did I not? Oh, no. I lost the image. No. No. I gotta get another old picture. Let's see here. U.S. Civil War soldiers. Images. Here, this one. Hold on. No. We'll take this one. Soldier. There's GFP again, and we want the deblur data. I'm going to keep a copy of this just in case. I think I'm having a path issue is what's going on. And I'm going to say soldier.jpg. Soldier.jpg. Okay. Cool. So there is a problem with the way that I'm saving this out. os.path.join string path out stored images base name.extension. I'm just gonna run this file. By the way, this is how you debug Python using VS Code. By the way, if you have any questions when I'm doing this, what the heck? It's supposed to debug. Is it debugging? Oh, a derf. Oh, it did it. It just overwrote it. Dang it. It's doing it. It's doing it. So reveal. It's doing it. But I replace. Okay. Now you can see it's blurred. Okay. Cool. Okay, so now I'm going to debug Python file this time, which is the right thing to do. Stop. Okay. What is this? Where is this putting this? Copy, debug console. Boop, 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 boop. So what's the problem with this? Why is this doing something weird? Oh. What the heck? What? How is this doing this? Hold on. I need to zoom for effect here because this. What? Okay, clearly something wrong here. So let's stop this because I don't want us overwriting that dude's face. Okay. Cool. So if we have the out path and this print image out path, image.parent. Absolute path where the image is. We have the image path, right? What's out path? Let's debug again. Debug. Boop. What we got in here? Data output. Fantastico. Image path. Fantastico. So this is the right thing. Out path is face unblur data output. Face unblur data output. Cool. Okay. So when we do this save restore thing, we are going to do the out path, which is a path object. So I can say something like this: out path dot join path restored, comma, this. And then I am right. I should wear a t-shirt like that says I am right. And I'll just wear it when I have arguments with people. And they're like, what does that shirt even mean? I could say something like, it's too technical, you wouldn't understand. But I am right. On a scale of 0 to 25, it's a very refined scale. How funny was that? Please make sure you fill out your surveys here. Okay, so save restore path. I am right. I think auto make dir. True. Cool. We'll auto make dir on this one. Okay. I don't know why we're making a whole bunch of extra variables. We don't need that crap in our lives. We don't need extra variables just being created for no reason. Okay, let's try again. Okay. Beep, 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 beep. Boom. Boop. Here we go. Here we go. Restored image is an ND array. It's not none. Save restore path. What? This I don't get. Data output. What? That is weird. Why is this so weird? What? Oh my goodness gracious. Look at that. That's embarrassing. Let's fix this. Base name. That's why we're getting that. I think there's a split. We'll split on a boop, boop. -1. Boop, boop. By the way, that was a little bit of Python wizardry. Did you see that? Did you see that? Yeah. Yeah. We are using Python indexing. News at 11. We'll do that. That's the problem. This thing is getting ski-wompedest. Okay, so we'll do this is weird. No wonder. No wonder. So base name equals base name dot split. Just OS path dot split name. Why am I even doing this? I'm just gonna say output. Or restored. Restored. Gosh, why am I making it so hard? You know what I'm saying? It's just, it doesn't need to be this way. It doesn't. All right, let's try now. Just a straight run here. Python score. Here we go. For all the marbles. For all the marbles. No, I should debug. No, I have faith in us. I have faith in us. Here we go. Python score.py GFP gang clean v1. We are getting some. Oh. Okay. Okay. So something else is happening, and I thought we had it Honestly, I thought we had it, but we didn't. Let's delete this. Goodbye. I don't think we need this. Let me stop it and start again. By the way, if you're not using Visual Studio Code for your Python development needs, you are missing out. Look at this. Stepping through stuff like a boss. Okay. So this looks right. I mean, looks right to me. Oh. I know what it is. It's a path object that I like to do path stuff with, but sometimes these older methods only like talk in terms of strings. So it's going to do it. I feel it. Delete. Boom. There you are. Look at this wonderful American hero now with a deep blurred face. Mmm. Mmm. American hero here. Civil War American hero. Let's side by side this. This goodness. So you can see that it actually did a thing. Mm. Thank you. Thank you. We did it. We did it. I mean, I'd like to thank my agent. I'd like to thank the many people who believed in me, who thought that I could make something of myself. Thank you. Thank you. By the way, I want you to see this like actually close up side by side, because you can see that it didn't do the background. Maybe we could figure out, but you can see that it's clearly much better. Look at that. That's cool, right? Let's go through the code, because I know there's some folks that weren't here last week when I did the thing. So basically, here I have a whiteboard a blackboard that I can use for this. Next thing we're going to do is we're going to try to get it to work in a web service in the next hour or so. So basically what happens is there is this thing called a model, a machine learning model, right? You basically saw me download it from Hugging Face, right? Last 2 weeks ago, I went through the rigmarole of like copying the code and all that other stuff, when in reality, I could have just downloaded the package. That's all we needed. And then what I do is I take this model and I write some Python code that loads the model, takes an image, right? That's the image. And it pushes the image. So this is like, here's the thought bubble of the Python file. What it does is it takes the image, pushes it through the model, and then out pops this refined image. That's what's happening. That's exactly what's happening. and you're like, show me the code. And by the way, the model, I just downloaded it from Hugging Face. Where are you, model? Model. Le Model. Here. I just downloaded it. You can see there's a paper model, and this is the pre-trained model. Literally, you just right-click, save as. Model. So I know Janice Q number 7 is like, we need the model. It's right here. Aquí está. Okay, now getting it to run as a service, that's a little trickier. Now, I will tell you, and here's the cool thing. Okay, let me make myself a little bigger here. Here's the cool thing about this. Putting models in production is hard. That's the hard part. So if you can do this, because the other day I was in a Twitter space, I think, and was it Twitter space or was it that other one? What's that other app called? Where sometimes I put it on while I'm coding, to listen to that Clubhouse, and they were like, oh, try with a different. Totally, I'll try with a different image. Manish is saying, try it with a different image. Yeah, I will. And they're like, so what would you suggest to do if I want to go into machine learning? I'm like, you could go to Hugging Face right now, download a model, make it work. And that's more than almost a lot of people. So the question is, we pip installed the model, didn't we? We pip installed. Okay, so let's go back to this drawing because I think we need to get into some more specificities here, because I think I want there to be some clarity. So let's go to yellow here. So when it comes to the model actually has, oh wow, arrows? No, I don't want arrows. How did that happen? No arrows. So the model has two parts, okay? And this is the important part. We have what are called the serialized weights. So ones and zeros, the serialized weights. And we have the model structure, so the thing that looks like this, and then this goes to this thing, the model structure. So this is what the weights, and these are the model structure. Now, what happens is when you're loading a model, when you're saving a model, you're actually saving this part, which are the model weights, the actual numbers. Let me make this bigger because I want to make sure we're having some clarity here. So these are the model weights that we're loading up. So when you're looking at that PTH file, the Python file here, these are the model weights. Now, in order to make the model weights work, you have to have the model, we have to have the model structure. Let me zoom in there. That was a little weird. Woo, whoop. This model structure is defined in code. And so last time, what I did is I basically pulled like the code itself, but we noticed that they had helpfully created a Python package for us. So we pip installed this, right? Then we used I think it was the Ganner or something, and told it where the weights were. And then we get this object, right? That's the model that we can then use to do this. Okay? Is that clearer? So you have the model weights, and you have the model structure. Model structure is the code. Model weights is the serialized weights. And so when you instantiate the model, you pass in the weights, and it hydrates it in memory. Okay. Try with a different image. Okay. Let's do that. I'm going to have to change it though, because if I do restored, it's going to overwrite this. So let's, instead of this, image path is a path. And I think I can say image path dot name. I think that'll do it. And then I can change this to rename soldier.jpg. Okay. Let's go to another one. How about this, gentlemen? Let me do one with some... This is the one we had before. Projects, face up blur, data. We'll say group. Group. Looks like we don't need this anymore. We're going to say group. Here we go. Different image. Let me move my face out the way. Out the way. Here we go. Wow, that's slow though. Group.jpg.jpg. Oops. Do you see it? Click this gentleman, American Heroes, here. American Heroes. Do you see it? It works. American Heroes. Okay, so now the question of how do we get this to run in a service? I don't know if I want to fix this. I don't care about the path dot. What's the stem do? I don't know. Let's try to run it again. See what happens. I don't know why I just didn't say name in there. Oh, Seth Freakolites. What are you doing, dude? The question is, are you going to make it an app? That's what I'm trying to do. Oh, that did it. Look at that. So I can delete this. Okay, so now we've got our code. We've got to envision. So if we're going to do this on the web, like if I'm going to make a website that calls this thing, ostensibly, I'm going to have to push a picture to it. And then I'm going to have to push a picture back. So I've got to find a way. In Azure Machine Learning, this needs to be run, by the way. Run. There's got to be a way for me to take bits too. So we don't even use this. Okay, so I've got to think of how to do this buffer stuff, so that I can run the image. So looks like we don't. I don't need. What did I even? What is this for? So there's NumPy. Looks like we don't. do anything with this. We do for sure do the I am right. So let's see if we can't switch this around to do everything in memory, so that I don't have to do file paths and stuff. Obviously, the model path is going to have to stay the same, right? And the model global. So the question is, am I going to try to make a website? Yeah, that's what I'm trying to do. That's what I'm trying to do in the next 40 minutes. Okay, so to initialize it, I think this still works. Now to run it, make sure that the model is still the global one that I just loaded. And what I need to do is I need to open this image up. So if I pass it a URL, it will know what's going on. So let's do this. So if path dot starts let's change this to image so that I know it's the actual image. And we're going to say this is a string for now. So if image starts with HTTP, then we're going to do something with it. Right? We have to load this up. And I have code that does that because I've done this so many times. We're going to use requests. I've done this so many times. That's why I'm doing it. So from PIL import PIL as PIL import PIL as where do I get that? Okay, from a PIL import image, right? Because we're going to use that because I've used that before, and then import requests, and then we're going to make sure to put pillow in here. Okay, cool, because that's the image thing. From IO import bytes IO, because this is what lets us do stuff in memory. Cool. So that basically opens the image. The next thing we need to do is we need to make sure this image is using the same color scheme. Because the problem is if we don't use the same color scheme, it might have a problem. So input image, which is this thing, and we want to do it all in memory, equals image.convert, and we're going to do RGB because I'm going to take the alpha channel out. Okay. Okay, so there's no more paths. Will this work? What is this? Okay, we'll try that. Okay. So in theory, if I pass it a URL, this should work. Let's try it. Okay, so let's find a URL here because let's find a different picture here. No, not this guy. This gentleman. Holy cow, this is a horrible URL. Oof, I don't want to use it. I don't want to use it. The URL is too crazy. What about this one? Why are these URLs so crazy? There we go. Okay. Okay. Let's see if this works. Because now we can, in theory, start posting image files to it if we want, right? In theory, like I can give it an image file. So let's do this. Oh, it did it! It did it! Okay, it did it. It did it. Cool. Yeah, it tried to upscale it. It kind of, yeah. But it tried. It tried. Okay, so that worked. Okay, cool. So now we can post actual images to it. But what if I want to post an image to it on the fly? There is a sneaky way to do that using base 64 encoded images. Is there a way to do this? Interesting. I wonder if I could make it so that I could run it. Wow, this is embarrassing. I might have to. I got to figure out a way to do that. Oh, I know what I'll do. Test image dot text. I don't think I got it all. I don't think I got it all. I don't think it's giving me the whole image. Did I copy it right? We don't need this thing anymore. We're grabbing this. Wonderful. Okay, cool. This is doing the right thing. We don't need this. So this is a base 64 encoded image. And the reason why is because I want to be able to JSON post an image. Okay. Let's try that. theory, it should be the same thing again, but we need to be careful here because I need to I need to see if it starts with the right thing. Else if image dot starts with oh gosh, wrong language, you goober. Starts with, and then we want to, this one is a test image. So if it starts with data image, because it can be a JPEG or a PNG. So we'll do this. What we want to do is we need to get that data part out. Data equals image dot split. And we want to split on this comma because see here, this is the default delimiter when we URL encode. So for example, if we're drawing on a canvas and you go to data URL, this is what it generates. And we want the second part of that, right? We don't want the whole thing. So B64 image equals base 64 dot B64 decode, right? Decode data, and we want the second slot of that. And then we want image equals image dot open B64 image. And what we're going to do is if it doesn't have that, we're just going to assume it's just a base 64 image in general. And we'll just do this. Okay. Okay. Let's see if this works. Hopefully this reads the whole text. So let's try it. Right, cool. So this is the right thing. Oops. This is the image. So F10. And by the way, the image we just did is this thing right here. Same Civil War dude. We'll split the data. Notice that in the 0 spot, we've cleared out this part. Okay, cool. Let's open it. Oh, shoot. UTF codec can't decode byte 0xFF, invalid start byte. UTF-8 codec can't decode byte 0xFF in position 0, invalid start byte. I wonder if I need to put it in like a buffer. This forces it to be all bytes. I think. Let's try it. Okay. Okay. Okay, it did it. It did it. Let's give it a different URL here and see if it does it again. So we'll delete this here. Let's find another picture. No, I just did that. Why do I click in the wrong thing? Okay, let's do this one. Somebody rosied their cheeks a little bit. let me do this again, but with okay, moment of truth. Cool. It did it. Wow. It really did do it. Wow, it really kind of made this guy look a little cross-eyed, though. Oh, question. Some questions here. What are you doing? I've been asking myself that for a long time. I am basically, what I decided to do is I wanted to show something a little different. Usually we're doing Rochambeau. But today what we've done is we've downloaded a model from Hugging Face. And the model from Hugging Face, what it does is it deblurs images. So we went to the GitHub, downloaded the model, this one, and I looked at the code so that I could try to make it into a web application. So like an endpoint to a web application. So that's what I did. So right now I'm testing it because if it's a web application, I've got to be able to either post it a URL for it to deblur, which is what this is, or post a base 64 image, because I know how to get a base 64 image from a web client to a web server. And so we're testing with these base 64 images that I literally just converted. And so when I say path this, it's basically running this particular picture, this original picture, and it's deblurring these photos, right? You can see it also upscales them. So this is what the photos look like originally. This is what the pictures look like after I deblur them using the AI model. Let's go back here. That's the difference. You see the difference? Not only because this is the size of the picture, you can see it also upscales the picture a little bit, but you can see their faces are much clearer, and it also eliminates this weird little tinge. And so you can see like it clears it up a lot. So that's what I'm doing, Abel, and I'm showing people how I'm doing it from scratch. 2 weeks ago, I started the process off, and it kind of wasn't working. We finished off in a kind of good place, and this week this 2 weeks ago. And this week, what we're doing is we're trying to now make it into a endpoint, to a web service. And so that's what I'm doing. Taking a model from Hugging Face into production. And right now what I'm doing is I'm cleaning out everything having to do with saving files. Okay, so now the other thing we need to do is we can't save the file. So we need to actually return we need to return a base 64 encoded image. I think that's what we need to do. But how do we do that? And this is the part that's going to be kind of fun. Let's see what this uses. This is using CV. I wonder if there's a way to write this to memory. Is there like a save to memory? This is file. CV2, I am right. Save an image to local files. I'm right. Saves it. It shows based on file name extension. Only 8-bit. Yeah. Or if the file format is different than the matte convert to and CVT color to convert, are you using? How about this? Yeah, we know what this is. Yes, I know. I don't want to open a file. There's got to be a I am read, I am right. I am right in memory CV2. How to avoid. Okay, that's not it. Oh, okay. Write OpenCV image in memory to bytes IO. Okay, so it looks like IM encode. Looks like IM encode is a way to write it, but to memory. Let's try that. So instead of saving to a file, we don't want to do that. What we want to do is we want to write to, why not write out as a temp and read then. So the reason why I don't want to do that is because I'm trying to avoid IO operations inside a web service, basically. It's because I'm thinking like 3 steps ahead. And so if the thing comes in memory and I go through a series of memory transformations, writing to the file would, I think it would cost bus time. And I want to make it a little bit faster. I don't want to have to save anything anywhere because I'm going to assume that this has no storage other than loading up the model. So let's do this. Let me add CV2. There it is, CV2. So I'm going to say CV2.im encode. We're going to say that we'll do a JPEG extension for all of them because I feel like it's going to get better compression. And then I am going to save out the restored image. And then this thing is going to probably be, what does this even return? Return value in a buffer. Encodes image into a memory buffer. The function IM encode compresses the image, stores it in a memory buffer that is resized to fit the result CV IM right for list of supported formats, blah, blah. The file extension, the output format, image to be written, output buffer resized to fit the compressed image, format specific parameters. I am right. Okay. So it returns return val and a buffer. I don't care about the return val. So we'll say buffer equals this. And we're going to base 64 encode this. Restored B64 equals base 64 dot base 64, and we want a B64 encode. Or is it decode? Encode, right? Because we have the image. And what we want to do is we want to pass in the buffer. And we want to get the string out of this. Okay, for this, I'm going to output the file. Because otherwise, what it's going to do is it's going to just print it all out, and we don't want that. Restored.txt. Okay. What the heck? We need to stop printing things, is what I'm deciding here. So let's take this out. Okay. Ready this. Is this? I'll just say restored. Oh, it's doing it. I just need to R equals and then I print out. Okay, this should do it. Let's delete this here. Oh, dokily, here we go. Cool beans. Let's see if we can base 64 decode image. What? Wait a minute. I think when I stringed it, Python added the B. Yep. Okay. I need to take the B colon thing out. Okay. Cool. Okay. Let's try this out because I think I know what's going on, and I think I know how to fix it. Here we go. We got 15 minutes left. We might not be able to. I need to still do a container here. Okay, so let's try something. So we're gonna say X. We'll try a string because what you're gonna see after. So this thing starts with here. It starts with this B colon thing. Right? Let me show you here. See this B colon thing, and then at the end, it ends with a this thing, which we don't want. So basically, it's basically like B colon blah 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 end. That's what it does. So what I want to do is I want to take the first two characters off, and then we want to go all the way to every character except the last one. Like so. So this thing will be 2, -1. Because we want to take that little, because it's a byte, we're converting a byte string into a byte, an array of bytes into a string. It puts B, single the whatever, and then it puts a thing and then it ends it. So this makes it so that it takes it off. All right, let's try again. Without the let's delete you, my friend. Okay, so let's go to restored. Control A, Control C. All right, so we know those methods work. So now what I'm going to do is I'm going to do the same thing, but I'm going to say R equals here, and we're going to do this one. For the other one, see if we get where are you at? We did it. Okay. Now the next step is to make this into a container that we can run in the cloud so that we can build $1 million empire whilst de-blurring images. Yeah. Yes, the Sethpire Empire. By the way, today's Boba Fett day in my house. Apparently, it's the last one. So, okay. So now we need to make a container that does all the right things. So it looks like this is what we want. We've gone from this thing. We've gone from this thing here to something super slimmed down. Like it's literally one file. We don't need these anymore. I think we tested these enough. We don't need this one either. Cool. Now all I need to do is I need to register this model. Let's see if I can do that. How do I do that? ML com here. How does one do that? How does one do this? Let's work on a container first, because I feel like let's work on a container. And here's the cool thing. I don't know if you know this. You can do something called dev container. Right? And inside of a dev container, you can actually do a couple of things, which is really cool. The first thing we need to do is we need to create a new file called dev-container.json, which describes the dev containeriness. And I actually already have one that I've used before. And I already even named it GFPN. So this is the Docker file. We don't have a Docker file, so let's do a new file. Docker file. Fantastic. And then we also need probably our requirements.txt, and then our conda.yaml. And I have some because remember we've been doing this on our Rochambeau, github.com. Rochambeau, where are you? github.com AI. Okay, so we have this one that I described in the AI cloud. This. this. So we want something like this, but without all the things, right? We need this. We don't need the Onyx runtime. Okay, cool. And then for requirements.txt, we have all of this. Okay. And now in our Docker file, we just need to come up with a way to get it. And did I have a Docker file that I could look at here? Environment. Yes. This one. This I've used this one before. So we'll use this one before. We'll do from boop run apt get update run apt get install. I have to install a couple of libraries. I'm looking at a template I have here. This is to get the image library stuff, and then we've got to copy conda.yaml to here, copy requirements.txt to here. Did I spell that right? Boop. Run conda env update the base one and file conda.yaml. We're building something from scratch. So this basically updates the base environment with these conda things. And I'm leaving Azure ML defaults in there, which because that's how it knows to run. And then I'm installing this thing, which comes from, the Hugging Face stuff. And now let's go to this thing to figure out what we need to be running. Let's do that. Maybe we'll do this. We didn't do the enhancement, but maybe we'll think about doing it later. I could take that. I could have taken that other one out because in the requirements.txt we added the GFPGAN thing. Okay. Okay, so now that I have a dev container, I should be able to... Oh, man, it's time for our walk-off music, my friends. I should be able to restart this in the dev container. Hold on. Let me change the name of this thing. GF... we'll call it the blur. Reopening container. So now I'm literally reopening this entire thing inside of that container that we're building right now. By the way, as this container builds, I want to remind you that coming up next week, join us Friday, February 18th for our Learn TV live stream. At 11 a.m. Pacific, analyze unstructured docs and more with Azure Form Recognizer with Vinod Kirpad. He's been on before. He's awesome. And at noon Pacific, 30 days to learn Azure AI fundamentals with Aishigul and Ruth. By the way, they're currently doing a 30 days to learn it. I should have written that down. where you can learn a ton of stuff about Azure, etc. Is there a link, friends, that we can share, Mrs. Producer? There's got to be a link somewhere. But that's what we're doing next week. Hopefully you've had a good time. So let's just recap what we've done today. We started out with Alvin and Paul talking about NVIDIA DeepStream. That was a cool demo, and hopefully you'll come back and show it. I'll cut it up and hopefully have the package so we can upload just the part that they did, and you can take a look at that. We'll see if we can get Paul's audio cleaned up a little bit. Maybe he'll redo the demo for me. Then we went to Hugging Face and downloaded a GFP GAN that we had started working on a couple of weeks ago. We didn't get to work, but now we've gotten it to work. I think we've got it ready to deploy into some kind of endpoint. So now, in theory, I should be able to go and just like put any image in there and deblur stuff. We didn't get to Rochambeau, but we did spend some time de-obfuscating what it means to download a model and use it. So that's what we did today. As always, my wonderful friends, this is going to take a little bit of time. I'll show you what that looks like next week. It's been a pleasure being with all of you. As always, if you ever have any questions, feel free to reach out to me on Twitter using @SethWarriors. You can email me at seth.warriors.com. Thank you so much for being here, and hopefully we'll see you next time on a live episode of The AI Show. Take care.